So 8.5b is talking about finding the two consecutive numbers between which a square root is going to fall, okay? Or, kind of the opposite of that, finding out which two perfect squares a number is in between. Okay, so we're going to show both of those on number one. There's two ways you can do this. You can think about what perfect squares surround this number. So that's 160. I know that 144 is a perfect square. That's 12 squared. And the next one has to be 13 squared. That's 169. All right, so those are the two perfect squares that surround that. That means the two consecutive numbers that the square root will fall between have to be those two numbers, that 12 and 13. If you don't remember these perfect squares off the top of your head, this is a pretty tricky strategy. So instead of doing that, we can just do exactly the operation that this is talking about, the square root of 160. That's 12.65. And not surprisingly, that's about halfway in between 12 and 13. It's directly in between 12 and 13. It's bigger than 12, smaller than 13. Okay. However you find this easier, that's the way you should be doing this. If you want to take the square root of that number and look at the decimal and figure out what numbers that's in between, that's fine. If you don't get that, if you see the perfect squares really easily, then you might be able to do it a different way. Okay, so on this one, I see 64 and 81 are the two perfect squares that's going to surround that. Or I can do the square root of 70 and see that that's 8.37. It's a little bit bigger than 8, a little bit smaller than 9, and again, the square root of 64 and the square root of 81 would give us those two numbers. When we're dealing with a negative, the only thing we want to be careful of is thinking about it on a number line. So let's just do this one with the square root of 325. That's negative 18.03. Right, so negative 18.03 is right about there, a little bit closer to negative 18, but it's important that you see that that's in between those two numbers, negative 18 and negative 19. All right, so in these next ones, we're going to fill in the blank. 125 is in between 121 and 144, so that means the square root of that number has to be in between the square root of those two, in between the square root of 121, which is 11, or the square root of 144, which is 12. The square root of 65 is in between 8 and 9, so that means 65 has to be in between those two squared, 8 squared and 9 squared, in between 64 and 81. These are the two types of examples you might see where you have to find the two consecutive numbers that a square root falls between, or the two perfect squares that a normal number will fall between. Those are the two kinds of examples. Blank is a perfect square between 30 and 40. Between 30 and 40, there's only one perfect square, and that is 36. There are blank perfect squares in between 50, and this should actually say 101. So in between 50 and 101, there are how many perfect squares? There are some number of perfect squares in between there. So I know that 7 squared would give me 49. That's too low. But I know the next one's going to be good. That's 8 squared. That's 64. That's 1. 9 squared. That's 81. That one's good too. And then 10 squared is 100. And that gives us the third one. So there's 3 perfect squares in between those two numbers. If the square root of a is in between 9 and 10, that means a needs to be in between those two numbers squared. So it needs to be in between, somewhere in between 81 and 100. You can put any number in there. I'm going to put 83. I don't know why. A could be any number in between 81 and 100. It can't be 81 or 100 though, because that wouldn't be in between. It would fall directly on one of those. All right, that last example is asking us to plot each of these on a number line. The first thing I'm going to do, I'm just going to figure out what those are as decimals. I'm going to figure out the square root of each of those numbers first. Square root of 15 is let's just call that 3.87. Square root of 19 is 4.36. Square root of 24, that's almost 5. That's 4.8. Really, 9 should round it up, so that's 4.90. Square root of 3 is 1.73. The square root of 6 is 2.45, and the square root of 8 is 2.83. One thing I want to point out, we did the square root of a bunch of numbers, and we got decimals. All of those are irrational numbers. When you do the square root of a number and you get a decimal, those are called irrational numbers. Every single one of these is an irrational number. All right, so we're trying to plot these on the number line. I want to carefully look at how many dashes are in between so I know what each dash means. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces in between. So that each one is a tenth. Each one is a 0.1. That's 0.1. That's 0.2, 0.3, so on. I can't possibly fit those in there, so I'm going to erase that. But each one is a tenth. So let's deal with this first one. I'm just going to go in order from least to greatest. D is 1.73, so 1 and 7 tenths. 1, 2, 3, 4, 5, 6, 7. D is a little bit past 1.7. Next one is 2.45. 2, and then 1, 2, 3, 4. It's a little bit bigger than that. It's actually in between those next two. So that is E, just bigger than that. 2.83 is our next one. So we have 2.4 there, 2.5, 2.6, 2.7, 2.8 is here. Our next one is 3.87. So that is 3, and then 3.1, 2, 3, 4, 5, 6, 7, 8. It's just in front of that 9, so let's put it right there. Just in between those two, that's our A. Now we have B and C, 4.36, this is 4, 4.1, 2, 3. It's a little bit past that. That's where B goes. And C is 4.9. I'm going to count backwards from 5. That's 5, so that's got to be 4.9. And that's our last one, that's C.